What I'd like to teach you is how to find the percent compositions of each element inside of calcium acetate. So the first step is to find the mass of this entire compound, and I'm going to use this table to help us out. Bam. So the first thing I'm going to do is write down the particular elements that I see in the compound. Right, so I see calcium here, so let's write calcium down, Ca. I see carbon here, but I also see it here. Now that's okay, it's the same carbon, right? Carbon is carbon, so I'm going to write carbon. I see a hydrogen, okay, not A, but I mean there's multiple, but these are the individual elements. And I see two oxygens, but I'm just going to classify that as one, it's one type of element there. Next is the number of atoms. Now we're going to take into account the number of atoms that we have of each particular element. So for calcium, there's only a subscript down here of a 1, and what that means is that there's one calcium atom. Now carbon, you just have to be careful here. Inside of the acetate anion, there are two carbons. One carbon there and one carbon here. And so that would be a total of 2, right? If you had only one acetate, but you don't have one acetate, you have 2 of them. So therefore, you would have a total of 4 carbons. Hopefully that makes sense. If in each acetate you have 2 carbons, but then you have 2 acetates, right? It would be a total of 4 now, because 2 acetates, 2 carbons in each, 4. 2 times 2. Then hydrogen, right? So let's just erase this. So for hydrogen now, we have 3 hydrogen here. There's no other hydrogen. But remember, this represents 3 hydrogen in acetate, in a single acetate, but you have 2 acetates. So therefore, there would be a total of 6 hydrogens. Okay, not 5, right? It's multiplicative. And then for oxygen, in each acetate you have 2 oxygens here, but you have 2 acetates in total. So that would be a total of 4. All right. Then what you're going to do is you're going to multiply those number of atoms by the mass of each particular element, and that's where the periodic table comes into play, right? So we got to look these elements up. So these masses down here, for calcium is 40.08, hydrogen is 1.01, carbon is 12.01, and oxygen is 16. Those masses will represent either the molar mass in grams per mole if you're calculating molar mass, or the molecular mass in AMU if you're calculating molecular mass. All right. So let's write those on down. So calcium here is going to be 40.08. The mass of carbon there was 12.01. The hydrogen was 1.01, and then oxygen is 16. Then to find the total mass of each element now in the compound, we're simply going to multiply this row on across. All right. So the total mass of calcium here is going to be 40.08. Because it's just one atom of calcium, and right, this is basically the mass. And then for carbon, there's 4 atoms, and you have each particular atom has a mass of like 12.01, right? AMU technically, but don't worry, the gram and per mole and all that stuff works out to be the exact same. This would then be 48, right? 0.04, and then 6 hydrogens, so the total mass there is 6.06. And then for oxygen, we have 64. All right. And then to find the total mass now of the entire compound, all it is, sum this column on up. When you sum it all together, it's going to be 158.18. And remember, we're finding percent composition, so this was the first step to find that total mass. All right. Now that we found the total mass of the element, what we're going to do, or what I'm going to do for you, is add another column. All right. Make it nice and simple, and it's just one more calculation. Bam. So now all we're going to do is take the total mass of that particular element. So for calcium here, the total mass was 40.08. And what we're going to do is we're going to divide it, by the total mass of the entire compound. So this was 158.18. So hence why we need to find that first. And then we're going to multiply it by 100. This is a simple percent formula, part over whole times 100. And when we calculate that, we should come up with a percentage of roughly 25.33-ish, right? 25.33. Maybe 34, depending upon how you want to round it, all right? But that would be then the percent of now calcium in calcium acetate. Similarly, we would do the same for carbon. So it'd be 48.04. We would take that and divide it then by the 158.18. Multiply that by 100. And then we would find the percent here of carbon now to be roughly 30.37. All right, 30.37. Let's put that in a nice little box. And then same thing for hydrogen, right? This would be 6.06. I'm sure you're identifying the pattern now. This is why the table makes it nice. Right? It helps organize the thoughts. We know exactly where to look. Makes it nice and simple. 158.18 times 100. Structures are very important when you're learning. All right, and eventually you might not need to create the table, but at the beginning, they're very useful. So the percent here would be about 3.83%. All right, and then last but not least, oxygen. So 64. I'm not going to put all the zeros because obviously it doesn't make a difference. It might make a difference for sig figs, but you know how I feel about that. Who cares? So this is then 40.46. All right, 40.46%. So those would be the percentages now of each single element in that compound of calcium acetate. And what should happen roughly if you added these together, if you added the exact values, by the way, you know, sometimes when you round, it might not be exactly 100%, but if you added those exact values, it should come out to be exactly 100% there. All right, not that you have to do that, just kind of a way to check. Make sure you didn't make any silly mistakes. But guys, thanks for tuning in. All right, I really do hope this helped. If it did, give us a hand, like, subscribe, tell your friends. We got thousands of other videos out there for you, right? So check it out, all right? Even if you're not taking chemistry, if you're taking physics, now or later, we got thousands of solved specific physics problems from the OpenStax book. Even if you're not using the OpenStax book, it's free. Go to OpenStax, OpenStax, S-T-A-X, and you can download the book for free, and we provide video solutions, all right? Very good way to study for your class. Thank you very much.